Hi, good morning, everybody. I thought I'd share some information around single stacks this morning, simply because I noticed that the South African Council for Architectural Professionals have made their um, professionals aware of the fact that they need to do grey water harvesting and they need to do um, get their clients involved with the various aspects of reclaiming water or salvaging water. So let's get straight into this morning's session. When we're looking at types of drainage systems that can be installed in a building, the standard says there are two systems, and the one is called two pipe and one pipe. We're not going to go into too much detail around that. It's just important that the standard says that you need to understand that the one that you pick or the one that you select for that specific building be appropriate for that building, and it satisfies the provisions of 443, which is basically the building regs as far as plumbing and drainage is concerned. When we look at a two-pipe system, I'm not going to overcomplicate it. I need to get to single stack. So basically what happens is you have got two pipes. The one pipe actually just collects all the soil side, and the other pipe collects all the waste pipes, and they are even vented separately. So there's at no stage other than further down the drain do you find that anything in a two pipe system mix. They're vented separately, everything happens separately, and it becomes um, a very expensive layout. If you had to look at a two pipe system, you'll see it's fully vented. We've got soil vent, and it picks up the toilets only or the soil only, and the same would happen for the waste side. So as far as commentary is concerned, or as far as comments around the system is concerned, in the two pipe system, soil water and wastewater are separated before the water enters the drain. These fixtures to a soil stack is connected directly to the drain, and the waste into a waste stack. The stack then has to discharge into a gully that's located between the pipe and the lowest water fixture. Basically what I've said earlier, and important to note that the two pipe system is used in where there are many sanitary fittings in ranges, or where fixtures are widely dispersed, or it's impracticable to provide discharge stacks near to sanitary fixtures. Simple example would be if you had to look at a hospital or big factory, especially hospitals, because you've got these vast rooms or wards, and you have one basin next to the door where the doctor or the nurses and that use. So from there to the outside of the building, and then you have little toilet cubicles for every other room or for each room, depending on which hospital you attend or which hospital you go to. But basically you're looking at something that would be able to pick up long distances, widely dispersed, or in ranges where you have office type buildings where you have 10 or 12 toilets next to each other, instead of having stacks, separate stacks there, you'd be able to connect to those. The other option that we do have is a one pipe system, not to be confused with a single stack. You'll find that if you look at this detail here, you've got a one pipe. That one pipe picks up soil and all the waste, but the big problem, or not the, well, the big issue with the one pipe system is that traps of waste fixtures and soil fixtures may be served by a common ventilating pipe, but you'll notice that although there's one ventilating pipe, each fitting is ventilated. And you can imagine in the buildings that we do nowadays, for you to have a trap vent on each of these fittings individually, it's a bit of a nightmare. Same would happen with this. If it's a range, you'll find that you've got a single stack, the toilets are vented, basins, each of these fixtures are separately vented, and they all end up in the same stack. Most important comment around the one pipe system, and that's where the biggest downfall comes when it comes to actually installing these stacks on buildings, is that yes, they do go down the same stack, and they have got a common ventilating pipe, but each of those traps or each of those fixtures need to be vented separately. And the note then goes on to say that where the design provisions of a single stack system cannot be met. So if you're looking, or we are going to look at 13 rules with regards to a single stack. And then from there, you can make the call, or you are in a position to then tell the architect, yes, your client might want to collect some grey water, or you might want to do X, Y, and Z. But if you cannot comply with these 13 rules that are applicable to a single stack, then you need to revert back to either a one pipe system, which we do not want, or a two pipe system, which is more expensive. So best option or easiest option would be to actually just stick to the single stack system. So give me a second here. The single stack system is essentially an unvented one pipe drainage system, in the sense that individual traps are not ventilated, and that one stack serves as both the main discharge component as well as the ventilating component of this installation. The single stack system is technically appropriate for residential buildings from 1 to 30 stories in height, and that's served by groups of sanitary fixtures. We'll have a look at that now. And commercial or public class buildings from 1 to 24 stories in height that are served by ranges of sanitary fixtures. The system can afford great saving in pipework, duct space, and labor, and where pipework is exposed, the appearance is more aesthetic. The only people worried about that would be your client and the architect. But this is the most simple and most economical system available for use in the majority of buildings, provided that the provisions of this subclause are complied with. In other words, what we are going to be looking at shortly, this system will work if you comply with the following 13 or 14 rules. I think it's 14, but I'll check now. Residential class buildings served by ranges of sanitary fixtures such as hostels and deep plan. Here we go. That would be like a hospital or a new system. And then they're not suited for this, or not suited to the system, because we have got soil and waste going into deep land buildings like hospitals, like clinics, like big factories, where you don't have the luxury of running separate pipes, etc., etc. Generally, the single stack system is the more economical system for buildings up to approximately 10 stories in height. When the limit of the single stack system is exceeded, the design requirements for the fully ventilated stack system should be reverted to. So in other words, we're governed by, although this is only a recommendation, it says it should. If we look at a typical layout of a single stack system, you'll see that 10400 Part B, in other words, the building inspector's Bible, a particular one pipe system in which trap vents are not required in terms of specific criteria. So if you meet that criteria, then we don't need to trap vent. So a typical example of a single stack would be a stack picking up waste and soil all around the same system with a vent. So the younger cousin, or the little booty of a single stack, would be a stub stack. So if you look at the definition of a stub stack, it's a straight 100 millimeter pipe, not more than 1 story. In other words, your ground floor or your ground story, with a rodding eye at the top. So you'll see even in the standard, it refers to a rodding eye or a cap at the top of the stack. And then if you look at the reasoning for that, is most guys that have done this maintenance bit before, you'll remember that if you open that IE at the back of a IE bend or a vent on bend, you do not have 100% access going into that pipe. And these sockets tend to end up ripping or breaking out that little access portal there. Just an indication of what that a stub stack should look like. Terminology before we hit those 13 rules. A sanitary group is a combination of sanitary fixtures comprising not more than 1 toilet, bath, shower, and sink. So if you look at that red area or that area there, a group being a group of people, so this would be a residential arrangement. And a discharge stack is the vertical pipe that conveys from that fixtures or more directly to the drain. And then if you look at the branches referred to, would be your branches going into that stack there. So basically, if you want to simplify it, this is a tree, straight trunk going up into the air, and we've got branches picking up there. In a group would be a residential building, but then the same stack could be, or same single stack could be used in a commercial type arrangement, like an office, like a industrial building. And there we have, they call a range. It's a number of like sanitary fixtures closely spaced and discharging to a common discharge pipe. So that branch picks up soil, and in the other option available, it could be a waste branch picking up all of these separate waste pipes, but also still in a range. So it says a number of like sanitary fixtures. So you can't have a horizontal picking up toilets, basins, urinals, all of that. They need to be of the same sort or the same type for that system to work. Okay, so this is just from the standard where we have a group of sanitary fixtures in a residential building. So you have a single stack picking up all these fittings. That is a group. So in the rules, when we get to them, we see if there's anything on the group side, that's where it refers to that group. Or if it refers to a range, this being a commercial type building, you'll find that a range would be fittings of alike, and they are connected into a common discharge pipe. So when you see a drawing, or when you see a building plan or a schematic or a layout that needs to be done on site, there are a couple of rules that we need to look at quickly. The following requirements shall apply with regards to a single stack system. It shall only be installed where the building in question is of the office class, which has sanitary ranges. We've just looked at that. And of the residential class, which has sanitary fixtures installed in groups. In other words, you cannot mix and match. You either have one system in ranges or you have another system that operates in groups, but you cannot mix and match. The next point is a bit of an issue for me. It shall not be installed in any residential building that exceeds 30 stories in height, and buildings that exceed 24 stories in height above the lowest ground level abutting that building. I can give you a heads up that due to our own doing, as far as plumbers are concerned, and the fact that we have design professionals not doing their homework, the current revision being looked at for 10400P would limit that to 3 stories. Anything more than 3 stories currently being considered being given to a wet services engineer so that they take responsibility for it. Simply because between contractor and design professional, we've not been able to nail down these systems to the point where they actually work. For the older guys in the room, you'll remember these. This is a typical trap vent. So no trap vent for the protection of any water seal shall be required in terms of these requirements. Okay, we'll look at 413, 2 and 3 now. But basically the problem, or one of the issues with this lot, is that this is like an air admittance valve. So this would actually be on that discharge pipe. And for you to vent each of these things, you'd have to start putting back access panels on baths. You'd have to have ducts behind the urinals and basins and all kinds of fittings, because at some stage these things do need maintenance, the spring and the actual cowl, and you've got, if something goes wrong here, especially along the coast with these things, you end up with these horrible stinking fittings inside the building. So the fact is, if we require or if we comply with the rules of a single stack system, no trap vents will be required. So let this nasty be a reason why we comply. Okay. Next point, the supplementary vent stack shall be cross-connected at each story above the highest fitting. So on 3 floors, we shouldn't worry about that, but there is a section in 10400 Part P and 10252 Part 2 that deals with auxiliary vents or supplementary vent stacks, which simply requires you to go above the fitting on that level. It says here at each story with a discharge above the level of the highest branch, which is normally your basin. So you'll find that on the basin, above that level, and above that level, so that that vent is completely dry. Any of these fittings flushing down the stack here should be able to draw air from that auxiliary portion. But I wouldn't worry too much about that. The discharge stack shall be continued upwards to form a stack vent. So if that 110 mil pipe needs to be extended to pass the roof, that pipe could have gone straight up through the roof, and from that toilet could have been picked up there. So instead of having these vents, and part of the reason we're looking at these stacks is that the standard says that they should be continued upwards without reduction. So when an architect wants to sign a rational design, or some design professional is intending on giving a rational design to the local authority or to the contractor like yourself for that matter, bear in mind that these design is got to be equal or better. So having a vent pipe or an opening under the window does not comply with the venting or the rules of venting. So whether it be reduced or open or simply just left somewhere, the rule says that you need to be continued upwards to form a stack vent. So if that vent is not continued, we've got a problem. The radius of the center line of the bend at the foot of the discharge stack shall not be less than 300 millimeters. In other words, no quarter bends, no short radius bends, no soil and vent bends underground because of back pressure. And at the same time, we're looking at access through that stack. If one had to open that smaller eye and then try and rod through that whole system, the fact that there's polycop hanging around that fitting already indicates that you might find some more issues on the same installation. So no offset shall be made in the stack unless a ventilating pipe is provided to reduce pressure, which might be caused by an offset. So we saw that toilet bent earlier on that first setup. We all know that it's easy enough, and paper is very patient. So when you do a design and you draw a straight line, but when you get to site, there might be a window, there might be an air conditioner, there might be anything on that wall that's in your way, or there might be a column or a beam or anything of that nature. And the standard allows for that by saying that, you know what, if you take that hatched area and you look at both these hatched areas, it says no connections permitted. So you're allowed to have that offset if you want, or if you needed it to avoid an obstruction. But important to note that that hatched area, no connections be made in that. So if one had to make a branch connection in the hatched area, in other words, basically in that same area that the other figure indicated, you have to once again back vent with a dry vent. So you'll see that both go upstream, so no water can get into it. And then you can take that back into a dry point higher up in the stack. So no offset shall be made. If it's not a straight line, you should know immediately there's either going to be a lack of connections in it, or there's going to be an issue with the depth of these connections, because if you look at 6231, you'll find that there's a limit between the invert of the lowest fitting and the invert at the foot of the bend of the stack. So that there determines, or the height of that stack determines that clear area that is left above that piece of pipe. All of that having been said, basically what we're looking at, and this is simplified to a very big degree, but if you have a stack or you have a stack pipe falling, water coming down there, you would have seen before that water clings around the side of the pipe. It drops down there in the supercritical flow, and you basically have a 25% of that pipe area effluent, which is clinging to the circumference of the pipe, and 75% area. So when you hit the bend, the water then does what is called a hydraulic jump. So that hydraulic, or the water, then jumps up and it starts hitting the top to where that dark black line is, and it becomes like a drainage plunger. It seals off that whole area where the air is supposed to be falling in the drain or following that drain line. And as that column of water moves forward, it basically sucks out the air from the traps, and it just dries out everything, or it pulls out all the air and water that is behind it, to make sure that until it levels out to 50-50 or a normal flow in the drain. You see, after that sealing off and the water moving in that column, as it slows down, the water starts settling down again, and we have air above the water, and it starts flowing like a normal drainage installation. So although this sounds like a lot of waffle, you'll see that there's a very good practical reason when it comes to saving or sealing water traps. And on that point of water traps, the requirement for a single stack is that the waste fixture trap shall be a P-trap that has a water seal of not less than 75 millimeters, or be of a resealing type of trap, simply because that 75 millimeters gives you enough pressure, even even when you pressure test and you start pumping up the lines, you'll find that 75 millimeters of water is enough to actually keep that seal or maintain that seal. Sorry. Okay, we spoke about that, the difference or the heights in it. Here you can see a typical example. The vertical distance between the invert of the lowest branch discharge pipe connected to the stack and the invert at the bend of the foot of the stack shall not be less than 450 for stub stacks. So we do that when we do our normal drainage, minimum depth, 450, and then 750 when it goes up to 5 stories, and 1 story in height. So what you'll find on most high-rise buildings is that the drainage goes through the parking garage or the lower level, and that whole floor or that 1 story is kept clear. So there's no back pressure from water falling 5, 6, 7 floors up through that stack. By the time it hits the bend at the bottom of the foot of the stack, there'll be a 1 floor or 1 story opening where there's no back pressure on these fittings. So you can see in this case, on a normal 450 drain with that fitting sitting here, you've got top and bottom interconnected. Never mind all the other wrongdoings. We're just focusing on the fact that the invert of this fitting and the invert of that fitting and the invert of the drain, anything that flushes from the top will end up getting your stack or your traps to gargle and move around. Okay, this is more a manufacturing thing, but also applicable for the guys that have fallen in love with the strap-on saddles or those boss saddles, where a waste branch and an opposed soil branch, in other words, that's the toilet, are connected to a discharge stack. The center line shall not intersect 200 mil below. So favorite place, like we saw in that previous picture, saddle goes in here. So what you'll find is that unless you take the center line that toilet and drop 200, no connections in that area, or in that case in this area here, simply because whatever you flush here would end up tumbling down here and it will end up affecting any of your fittings. So you either need to go above that toilet or you need to go below that 200 so that the water can hit the pipe and start working its way down without flushing directly into the opposing line. So the strap-on saddle fanatics, it's something for you to consider. And then almost done. The inlet of a branch discharge pipe or a fixture discharge joining stacks of equal diameter, in other words, toilets, double junctions, shall be swept in the direction with a radius of not less than 50 millimeters, here you see, or shall be at an angle of 45 degrees, so that when this thing flushes, the water would then drop down instead of across, and it would go down instead of across up into the other fitting. So when you get to your merchant this morning and you ask them for a double junction and it looks like that, then you know you're more than likely going to have a problem, because this does not comply with the requirements of having that thing checked. The following requirements shall also apply to a single stack. Each fitting shall be separately connected to the stack. In other words, you cannot hop onto a line that's already on its way somewhere and then we'll join this one with that one, or we interconnect 3 or 4 or 5. In this case, I think 5, if I remember correctly. So you've got 5 fittings interconnected running into a, which is not even a single stack. It's like something they put together. So each fitting onto its own in the stack. No interconnections, not in the floor, not in the wall, not outside. Everything goes into the stack separately. And then not more than 2 sanitary groups installed in any fitting shall be on that same level. So that's why we have double junctions. We don't have triple junctions and we don't have quadruple junctions. It's simply down to making sure that on each level that we connect, or each story, no more than 2 groups. In other words, you have 1 and 2, and we move on to the next level, or whatever happens there would go onto a separate stack or a different stack than the original one. A discharge stack of not more than 2 stories. Remember, we're talking 2 stories. In other words, ground story is 1 and first story is, so we're looking at a double story building. You could have a maximum of 2 groups on that stack, could still discharge into a stub stack. In other words, if you're coming down and you facing a garage door or a opening of some sorts, you could still divert that 2 stories down to a stub stack with access on it, which would mean that that pipe would get across and into the drain with access, obviously with access over there, which would not then contravene any other acts or regulations. And then we spoke about the supplementary vent stack sizes, and we look at the requirements. So less than 10 stories or less than 10 floors, looking at 110 millimeter stack, and you'll find that for that, there is no requirement for cross venting or auxiliary or supplementary vent stacks for up to 10 floors. Thank you very much.